Hello everyone, and welcome back to my channel. My name is Ines. I love everything AR and VR related, and today I have another little workshop for you. Last week I went to Oxford and participated in the 3D for Ecotech Interdisciplinary Summer School at the university, where I met a bunch of really smart PhD students who are researching in the field of forestry. We went to a forest, we did a lot of LiDAR scanning, and I was basically there to show them a little technical background, like how AR development looks like. So I showed them the whole workflow from cleaning up their 3D scans, throwing them into a software. In this case, we were using 8thWall because it's just very beginner friendly, their web studio. As always, I promised to record the whole workshop and put it online. So here we are today. Without further ado, let's get started. This is what we built in the workshop. So I used a 3D scan of a tree and added some measurement devices that they showed us in the forest, how you measure, for example, the soil moisture, or you measure how much a tree grew in the last year. And here I added 3 devices as an example. So you can place the tree in AR and then click on the different devices and it will show you more information. So now we are in Blender. And I already imported a 3D scan of a tree, and as you can see here, it's kind of fragmented. Like if I would move this object, you can see it actually consists of 3 separate objects. So that's not very good. So the first step to clean it up would be just to select everything and press Ctrl J, which joins all of the objects into one object together. Now, if we go into edit mode by pressing tab, or you go over here and choose edit mode, you can see that the whole mesh is there. But if I select all the connected polygons around this specific one I just selected, I press Ctrl L, and now you can see it is one mesh, but it's still puzzled together from multiple different pieces like this. And this can get problematic if we are working with the texture or if we want to reduce the amount of polygons later on. So to fix this, we can select everything by pressing A or over select all. And then we go into mesh, clean up, and merge by distance. And this means that all of the vertices, the little dots in 3D space, if they are close together, like if they're kind of overlapping, we are merging them into one dot. So we can change the value here. So now we already removed over 50,000 vertices, so that's great. And if I now press Ctrl L and connect all of the neighbor faces, basically, we can see that now the whole tree gets selected. So that's really good. There are still a bunch of objects that floating around here, that leaves, I guess. So I select all of them by just using the Shift key and tapping the faces. And now I do the same again, Ctrl L. So I select all of the connecting faces and I delete them by pressing X. So this looks much more tidier, but the resolution of the mesh is still pretty high. There are a lot of polygons in this model, and to get a really nice running, smooth AR experience, you want to have as little polygons as possible, because otherwise it can get laggy or it doesn't work on the phone. So to fix this, Blender has a built-in function which you can find in the modifier tab. It's over here. So you click on the modifier tab and add the decimate modifier. And this is a very non-destructive way of working with meshes, because now I can select a ratio, let's say 0.1. It calculates a little bit, and you can see, let me put it to mesh view. So this is the original mesh with all its polygons. If you enable the decimate modifier, you can already tell that it's not that many anymore. It reduced all of the polygons that didn't really add much to the geometry itself, because the side of the tree was flat, for example. It merged them together and just made one big triangle for that flat space. The only thing we need to be aware of is that it also tries to calculate the texture at these specific points. Like, for example, here you can see the texture looks a bit stretched because it just created a new polygon here, where before there were 20 polygons. It's now one polygon, and it tries to guess what the texture there should look like. And this does not look that great. So I think I need to increase the ratio a little bit so these fractals, they won't be as noticeable anymore. What you can see over here when we look at the transform panel, which you can find if you click on item, the item tab, the dimensions are very small. Like, this tree is what, 1.5 centimeters high, so that doesn't make any sense for a tree. We will just scale it up by pressing S and just check once in a while. I think I want to scale it up to be like 2 meters or something. And you can also see it's kind of floating a little bit, like these green and the red line, this is the ground floor. And the orange dot here, that's the origin point of the tree. Either we can go back into edit mode, select everything by pressing A, and then moving it down by pressing G. Or you can also use the tool over here to move it down, so that it kind of roughly lies on top of the origin point. Then if we go back out into object mode, now if we, for example, rotate it, it rotates very nicely around the origin. Now, since we changed the scale and the origin point, what we want to do is also apply all of these changes. So we select the object and we go to apply and set it to all transforms. We want to apply all transforms: scale, rotation, and position. So we are done with this part. I also prepared the measurement devices in Blender. This is just very simple low poly object for now. I exported all of these three and also exported our final tree. And you can find all of those assets in the link below. There will also be the presentation with all the links. That's basically all we need to do to clean up our model. Now we want to export this object with the modifier applied and everything. So we just select it and go to File, Export, and then I like to choose a GLB format, because it already holds all the information inside. So the mesh and the textures and the material is just all in one object. So that's really good. Let's call it tree asset, that's fine. And I want to go under data, mesh, and apply modifiers. Here it's already checked, but if you are exporting your GLB with modifiers, you need to, enable this, basically. Okay, so welcome to 8th Wall. So if you are new to 8th Wall, then you should probably check out the project library and just look into the different templates and see what you can use for your own project, because sometimes you just need to adjust one or two things, or maybe add another script to reach your goal, so you don't have to reinvent the whole wheel. We will go with a world effect. So I will just select this one, and then you will get a little summary of what the template will do. And you just click on Clone Project. First, we need to give it a unique URL name. So this I will call workshop. And create. Let's just go through the panels real quick. So here in the middle you have your viewport. You can navigate it by pressing down the middle mouse button or the right mouse button to pan around and move around the scene. Of course, if you scroll, you can zoom in and out. If you press Alt and click with the left mouse button anywhere, you can rotate your scene view. On the left side here is your object hierarchy. So this is everything that is inside of your scene. We have the light, we have the ambient light here. This is just that you can see your content, the camera, and there is a ground plane. This just belongs to the template. It also has a script on it already. So to see what the script does, you can go into the play mode, which is the little arrow up here. And this will load a simulator. So it's basically just simulating a real world environment. And now if you tap the ground, there are some cute trees spawning, which is very fun by itself and kind of fitting for a forestry workshop. But we actually want to do something else. We want to have a tree in AR and show some info text next to the tree. So for this purpose, I need to import my tree and my devices, my measurement tools. So I added all of these assets also into the folder that I will link down below so you can follow the tutorial. First, I will import the tree scan. So I just drag and drop it in here. This is our files panel, I would say. So all of the assets that you import, they will be collected here. If you click on it, you get a little preview what it looks like. And you can set some settings if you like, but we will just leave it how it is. And to see it in AR, we just drag and drop it into the scene. And there it is. If you want to focus on a specific object, you can press F and it will zoom in. And again, with Alt and the left mouse button, you can rotate around it. Now let's delete the ground plane because that belongs to the template and we don't really need it. And let's see if our tree shows up correctly. Alright, so it does show up. It's a bit small. So what you can do is click on the tree scan object and just set the scale to, let's say, 5. That looks a bit more realistic. And now we also want to add all of the measurement tools. So I will select all of the dendrometers and drag and drop them into the project. Let's start with the point dendrometer. I will just drag and drop it on top of the tree scan, which automatically makes it a child object of the tree. And that means if I wanted to reposition the tree, I can move it around and the dendrometer, which we can see here, will follow its position. So it's basically inside the folder, the tree scan folder, and we move it together. Okay, so the camera is looking from this side. This means this is the front view. And I want to position this point dendrometer on the left side. So I will move it back here. And I need to rotate it because these two cylinders, like the screws, they attach to the tree. So I go over here in the inspector panel and I will just rotate it 100 degrees on the y-axis. Moving it closer in. And now I also need to rotate it slightly. So I will use the rotation tool up here and just grab the blue circle to rotate it. Okay. I think that looks pretty good. I will also do the same with the band dendrometer. So dragging it onto the tree scan and using the positioning tool to place it where it looks good. next is the soil meter, soil moisture meter. That belongs onto the ground, so I will just leave it here. Now the next part is to make them even more informative and add these little text panels. To add text elements to the scene, we can click on the tools. So for example, the band dendrometer. And I want to create the text panel as a child of the band dendrometer itself. So if I'm moving this object, I want to also move the text panel. So I select the band dendrometer and I go right click, new, and then under UI element, I want to select the frame. So a frame is basically just a background for our text. So let's move it to the right of the band dendrometer. It's also very big, so let's scale it down to, let's say, 0.5. And I also want it not to be perfectly square, but kind of rectangular. So I will set a height of the panel to like 30 and maybe a width of 80. Okay. Now we want to add a text. So right click on the frame, new, and then under UI elements, select a text. This will be our headline. So I will just call it band dendrometer. And I hope I'm spelling this correctly. Let me actually check. Since we are doing an educational app, oh, it's actually dendrometer with an E. I will set the font size to something that is not 90, maybe 8.5. And now I will also add another text element for the description. So let's say help to measure the tree growth. You can see it automatically added the text to the right of the title instead of underneath, and there's also no arrows so we can position it. That is because the frame already offers us a very convenient way to decide on a layout. So to move this text underneath the title, we go on the frame, we select property, and we want to add a layout property. So now this little panel appeared, and we can decide in which way the children object will be layout, will appear. So if I select the arrow down instead of arrow right, we can see that now it makes a column instead of a row. That's what we want. We also want to set a gap between the children, in this case the title and the description. So let's say 5. And now I want to go back into the description and I set it to text align left and set the font size to something smaller than the title, like 5. You can see that the description text box does not reach the end of the panel. That is because the width is set to 70, whereas the frame is set to 80. So to change it, I just write 80 in here. There's a few more things that I want to do to style this text panel. You don't have to follow everything, or you can also just play around with this by yourself. But for example, I don't like that all of the text is like glued or like stuck to the side of the frame. So I can add a padding over here. Let's say 3, left, like top and bottom, and also left and right. The gap is a bit too big, so let's say, yeah, just 2 should be fine. And then I can also change the color of the panel. Let's say it should be a dark green panel with the opacity of 0.8. And I also want to have round corners, so that's really cute. So I will write something like 5. All right, we can copy and paste this panel now for the other two measurement tools. So you go just right click, duplicate, and drag and drop it under the soil moisture meter, for example. And I want to position it right next to or above this little tool. Of course, I need to name it correctly. So this is a soil moisture meter. It doesn't fit into the frame, so I will just increase this a little bit. Measures the soil moisture. Not the most sophisticated explanation. That could definitely be a bit more information in there. Now I copy and paste the frame again and set it as a child of the point dendrometer and position it on the left side of it. So again, I'm renaming it point dendrometer. Let's see how that looks like in AR. So we press play and wait for the simulator to load. Looks really good. So now we already have a kind of educational AR application that we could share. But I want to add a little bit of interactivity here because we don't want to overwhelm the users with so much information at the same time. So I only want to show these panels whenever I click on one of the objects. So let's go here under the plus in the file browser. We select new file and create a new component file. Let's call it tab to show. And if you press enter, a little code editor will open here. And it already gives you kind of a template for all the different things that you could use. But we won't need most of it. We only need the state machine for now. A state machine basically helps us to keep track if we have tapped it or not. And we want to change this state to default initially, and whenever we touch it, we change the state to touched and call a function when that happens. For now, we only need one line of code to detect the touch on the object. So every time this event happens, which is a green touch, we set the state to touched, but only if the target of the touch is the object that the script is on, and that is referenced in the script as EID. So now every time we touch the object, the EID, we set the state to touched. So let's save the script with Control S, so you can see the little saving icon up here. For this code to work properly, we need to define the touch state in the first place. So we start with ECS, which is basically the toolbox that 8-Volt provides with all the functions that we can use. And we define the state touch. And now we want to listen every time we change the state from default to touch and call a function whenever that happens. So now we can add underneath here, when we enter the state, we want to call a function which looks like this. And in here, for now, I only want to print out a debug message in the console. So let's say console log touched. Control S to save it. And now let's see what happens if we go into the preview mode. I have a console down here. If you don't see it, you might go under simulator and check this little tick. Let's touch something, and of course nothing works. Why? Because we forgot to add the script to the object. So we go to the point dendrometer. We want to select a new component, custom components, and then tab to show. Now the script is on the object and we can actually detect the tap on this object. I will do the same with the band dendrometer, new component, custom component, tap to show. And also with this one. We are here, and now if I touch an object and I click, I will get a little debug which says touch. But what you also might notice is that it only triggers once, and that is because we only call this function whenever we change the state from default to touch, but we never get out of the touch state. We don't reset the state. So if we want to be able to toggle the text panel by tapping on it again, we need to reset the state every time the touch is over. So let's copy this on event state and add it underneath here. The only thing we need to change here is we want to detect the end of the touch. So that's the very moment your finger leaves the screen, and we don't want to get into the touch state. We want to get into the default state. So just resetting it back. So now if we press save, it will start to build the app once again. You can see the progress up here. And once that's done, we can select it. And now every time you touch the object, it actually triggers the touch function. So the setup is already there. Now we want to have a reference to the child object of each one of those, which is the frame, and just disable it and enable it whenever we touch the object. So we want to start by hiding all of these text frames. So you click on the eye next to the frame and not the tick, just the eye. That's the default state, is that they're hidden. And now we want to actually get a reference to the child object. And we can do that by writing in the state machine up here. We define a new variable, which is all children, and type children. And now we can form an array from all of the objects that the program finds underneath the parent object. So from world, get children, and ed is again the reference to the object that the script is on. This needs to be capitalized. Okay. So now we have an array of all children. So if we would have multiple frames like this, the array would be filled with two objects, these two children. But we only need the first child of this array. So we define another variable, let's say first child. And now we take our array, all children, and only get the very first one. So we add a 0 in square brackets afterward, because the array always starts from 0, not from 1. Now it gives us a little squiggly line and it says it's never used. So why is it even here? But we will change that ASAP. We will go back into this function where we also give out the debug message. And we want to use again the toolbox. And now we want to access the hidden state. So we write hidden and remove that state from the child object. So we want to remove it from the first child. So now the hidden state is there. We remove it and it shows up. So amazing. The only issue right now is that it just stays visible. We want to toggle it on and off whenever we tap on it. So for this, we want to use a bool variable. Let's define it up here. We're using the toolbox. We define a variable called panel shown. And in the beginning, it's set to false. In here, and I also want to write a separate function so we can toggle it on and off in the touched state. So let's set up a function by writing const toggle panel, and then we need to do a equal sign, 2 brackets, another equal sign, and a arrow, and squiggly brackets. In here, we want to write a very simple if statement. So if the text panel is currently shown, we want to hide it with the tab. If it's hidden currently, we want to show it with a tab. So let's write if toolbox panel shown. And if we leave it like this, it automatically means if this is true. If you want to check if it's false, you can add a little exclamation mark in the front. I will just leave it at that. If the panel is shown, we want to hide the panel. Oh my god, my spelling is really bad. Else, so anytime it is not true, we want to show the panel. Easy as that. Also, we want to update our bool so it is always up to date with the current state of the panel. Otherwise, our if statement doesn't work anymore. So in here, we just set the panel shown bool, panel shown, to false, because at this point it will be hidden. And in here, we want to set it to true. That by itself doesn't do anything yet. We're just updating a bool that we use to check. So let's move this line where we remove the hidden state into the toggle function where we want to show the panel. And we also added in here, and just instead of saying we remove the hidden state, we want to set the hidden state. So it just does the opposite, basically. And now I want to call this function every time we tap. So I will call the toggle panel every time we move from the default to the tap touch state. Now I save. And let's see. Let's wait until it builds the app again and test. Okay, we tap it, it shows the panel, we tap it again, and it disappears. Amazing. This is already much more fun than just looking at the tree. Interaction is always a great way to engage the people and teach them something in a fun and playful way. So if you want to test this scene on your phone at any point, you can go under Live View and scan this QR code with your phone. It will open the website and you can try out the AR effect immediately. If you're done with it and everything works how you want, you need to build it. So it's actually also live on the internet and you can send the code to whoever you want. For this, you want to make sure everything is built correctly, everything is saved. So press the build button. And 8thWall comes with its own Git functionality, I guess. If you're familiar with GitHub, you can go under land. And here, all of the changes that you did will show up. We need to add a little description, what we actually did. So we built a really awesome AR effect. And then we click land files and publish. And this will update the code in the cloud and also the QR effect. So every time you make a change and you want to push it to the live link, you will need to do this step. So if you haven't published the effect before, there is another extra step you need to do, which is go to publish. And now we want to set it to public. So you click the little radial menu here and then go to publish. You can give your project a title, for example, tree measurement tools. Put a description there. You can also add a cover image if you would like, and then you press done. And that's about it. Once this is saved and built correctly, we will get the QR code and the link again. So it looks like this. If I open the link now, this is how the web version of your AR effect will look like. So this will be your title image, and then it will prompt you to scan the code or just go to this link on your phone. And then you can like try the AR effect. And as I mentioned, all of these files, the 3D files and the script, is all accessible over the link in the description. So make sure to check it out. So that was basically the whole workshop. I was super happy that a lot of the participants could actually follow through with everything. It was not a lot of time and they did really, really well and actually had an AR experience in the end that they could try on their phones and bring it home with them. That was really cool, and everybody was really excited about AR, which of course makes me really happy. So if you have any other questions about this project or ideas for more projects about AR in general, then please leave a comment below and like this video if you enjoyed it. If you're interested in more AR development or XR topic, then feel free to click the subscribe button. I would really appreciate that. And I hopefully see you very soon. Bye!